Hi, hello. This is related to periodic properties. The electron affinities of NOSCl are in the order. Chlorine is highest, so you need to go with these two. Then oxygen, sulfur, you check. Sulfur should be great. Which one of the following is the correct order of the size of the iodine species? Negative ion bigger, then positive, then neutral, then this one. Ionization potential of X is equal to magnitude. Ionization potential means X is losing electron to form X plus. So just think opposite of this, X plus electron gives rise to X. So electron affinity of X plus. Al plus 3 is smaller in size than, this is than, sorry, Mg plus 2 ion because nuclear charge of Al plus 3 is more than magnesium plus 2. Oxygen minus 2 Sa plus 4 isoelectronic ions if the ionic radius of O minus 2 is 1.4. Anion bigger, cation smaller. So the value should be less than 1.4. Less than 1.4, you can go with this. The process that absorbs energy is, okay, this is electron affinity, this is electron affinity, this is electron affinity, releases. This is second electron affinity, Ea2 positive. Atomic radius is almost same for zirconium and hafnium. Okay, so this you can see scandium, titanium, vanadium, yttrium, lanthanum, actinium, zirconium, hafnium. We discuss in class 3D to 4D series radius increases, but 4D to 5D the radius remains same. So zirconium, hafnium. Which of the following has the least ionization potential? Least ionization potential. Blindly you can go with the cesium. The first four IP values of an element are 6.4, 12.2, 52.3, 60. So here sudden jump is there. Sudden jump means it can lose 2 electrons easily. Valence electrons are 2. That means it is M plus 2 type of category. Okay, X mentioned, so X plus 2. Phosphate mentioned PO4 minus 3. So the formula is X3 PO4 taken twice. Good question. The correct order of IP2 of this is a very standard question, O, F, and C. You know the reason? Okay, now IP2 means one electron gone already. So this is nitrogen, this is oxygen, this is carbon, this is boron. Nitrogen half field stability. So this is great. Which of the following isoelectronic ions has lower first IP value? Isoelectronic ions lower first IP value. Okay, so the nucleus power should be minimum. When the nucleus power is minimum, it can lose electrons easily. So that should be S minus 2. All are having same electronic configuration. So same stability will be there. Extra what you need to see is minimum nucleus power that you can see in S minus 2. 178 is first ionization potential, 348 is second ionization potential. Just add these two. So that is plus 526. M gives rise to M plus, delta H is 100. M gives rise to M plus 2, 250. The correct statement is, okay, this is 100 electron volts, this is 250 electron volts. M directly gives rise to M plus 2. That means M plus gives rise to M plus 2 is by 150 electron volts. I think all statements given are correct here. Correct. IP1, IP2, IP3 and IP4 of an element are 6, 18.8, 28, 120. Here you see sudden jump is here. That means valence electrons are 3. 3 valence electrons are there. This is a good question actually, because the molecular weight of the oxide is asking. So A plus 3 charge, oxygen minus 2 charge. So the compound is A2O3. Its atomic weight is mentioned 2. So 2x. And 2x is the only option. 3 oxygens are there, each oxygen 16, 16 3 is 48. So I think most of you make a mistake here, or otherwise you may skip this question. But it's an easy one. Okay, now what is the electronegativity of phosphorus, silicon, and sulfur? Sulfur is greater. Cross the period increases. Sulfur is greater, sulfur is greater, sulfur is greater. So first two options gone, then phosphorus. The correct order of electron affinity among the following is chlorine is best. Chlorine, fluorine, bromine, iodine. EA and IE values of an element are 1278 kilojoules per mole and 348 kilojoules per mole respectively. its electronegativity on Mulliken scale is, you know the formula, okay, 1278 is ionization potential plus 348 divided by, you need to divide here with 5.6 when the value is given electron volts per atom, and kilojoules kilocalories. I gave you some formula, just apply that formula, you will get it. I am not solving, you have to solve. Identify the correct statements. Electron affinity of phosphorus is more than that of nitrogen. Yeah, this is the correct statement only. Ionization potential 1 of oxygen is more than that of nitrogen, wrong. This is wrong statement. Size of aluminum plus 3 ion is less than that of magnesium plus 2. This is again right. This question is there already in this paper. Somewhere we got this one. Okay. So use sometimes to answer such kind of question. Basic nature of calcium oxide is more than that of, no, barium oxide is more. So A and C are correct. According to the Pauling scale, the electronegativity is measured with Xa minus X equal 0.20 10 to delta, and that is this one. What is delta? The correct order of basic nature of K2O, Na2O, and ZNO. ZNO is transition measure, so that should be least. And down the group increases, so K2O should be greater. The electronegativity of fluorine and polyene. So fluorine is the best, 4.0, highest. The number of oxides which are more basic compared to Na2O. Okay, compared to Na2O. In the following oxides, Li2O is less. Is asking Na2O, and down the group increases, K2O, CS2, Rb2. 3. A plus gives rise to A, 2 electron volts. 2A gives rise to 2A plus. So it's reverse if you write A gives rise to A plus is delta H is equals to plus 2. So for 2A gives rise to 2A plus, delta H will be 4. Very simple answer. The atomic number of element with the highest electron affinity. Highest electron affinity is for chlorine, atomic number is 17. Most electropositive element belongs to which group of the periodic table? Electropositive elements are always in alkali metals first group. Thank you, dear buddies.